Imagine you're chilling outside on a sunny day. The vibes are immaculate. You're soaking up some rays, maybe scrolling TikTok, just existing. Now, what if I told you that in that exact second, the sun, the literal center of our solar system, just vanished? Deleted. Completely wiped from the server. Are we immediately cooked? Do we instantly freeze in pitch-black darkness? Nope. You would sit there for exactly 8 minutes and 20 seconds, totally clueless. You'd still see the sun in the sky. You'd still feel its heat on your face. The birds would still be singing. The gravitational pull keeping Earth in orbit would still be holding us tight. For 8 whole minutes, humanity would just be living on borrowed time, catching rays from a ghost star. Why? Because the concept of now is a total scam. The universe has a massive ping delay. Light, the absolute fastest thing in existence, still takes time to travel. When you look at the sun, you are looking 8 minutes into the past. When you look at the stars at night, you are looking thousands, even millions of years into the past. Technically, because light takes a tiny fraction of a second to bounce off your phone and hit your eyes, you have never, ever experienced the present moment. You are quite literally trapped in the past. Today, we're ripping the lid off reality. Time isn't a clock, it's a fabric. It bends, it stretches, and it completely breaks down. Stick around, because by the end of this video, your brain is going to be fundamentally altered. No cap.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
What's good, Spark Squad? Welcome back to MindSpark, the only channel on YouTube that actively tries to give you a 4K existential crisis before lunch. I'm your host, and today we are talking about the most unhinged, confusing, and absolutely wild feature of our universe: time. We treat time like it's this rigid, bossy thing. You're late for work, your pizza takes 20 minutes to deliver, you have to wait a whole year for your birthday. We think of time as a straight line, ticking away at the exact same speed for everyone, everywhere. A universal metronome. But about 100 years ago, a guy named Albert Einstein stepped up to the whiteboard and said, "Hold my chalk." Einstein completely destroyed classical physics. He let him cook, and he served up the theory of relativity. He proved that time is not a straight line. It is a physical dimension, woven together with 3D space into something called the fabric of spacetime. And just like a piece of fabric, time can be stretched, warped, and completely twisted. Today, we are diving deep into the weirdest time glitches in the universe. We are talking about how speed slows down aging, how gravity gives you negative aura, and why the past, present, and future might all actually be happening at the exact same moment. Buckle up, lock in, because the physics of time is about to get completely unhinged. Bet. All right, let's start with the absolute wildest cheat code in the universe: speed. According to Einstein's special theory of relativity, space and time are part of the same VIP club. And there's a bouncer at the door, and his name is c, the speed of light. The speed of light in a vacuum is roughly 186,000 miles per second, or nearly 300,000 kilometers per second. It is the ultimate speed limit of the universe. Nothing with mass can go faster than it, but here is where the universe's code gets super glitchy. The closer you get to the speed of light, the slower time moves for you relative to everyone else. This is a phenomenon called time dilation. Let me break it down with the famous twin paradox. Say you have two identical twins. Let's call them Chad and Brad. Chad decides he wants to be a terrestrial NPC and just stay on Earth. He's going to work a 9-to-5, pay taxes, and scroll social media. Valid. But Brad has absolute main character energy. He hops into a spaceship capable of traveling at 99.9% the speed of light and blasts off into deep space. Now, let's say Brad travels around the cosmos for exactly 1 year from his perspective. Inside the ship, everything feels normal. His watch ticks normally, he eats his space rations normally, his Spotify playlist plays at the normal speed. But because he is moving so insanely fast through space, his movement through time has to be nerfed. The math for this is wild. The time dilation equation, using the Lorentz factor, looks like this. T equals sign frac t sqrt 1 frac v2 c squared, where t is the dilated time, v is the velocity, and c is the speed of light. Because v is so incredibly close to c, the denominator gets tiny, making the time experienced by the stationary observer massive compared to the traveler. When Brad lands his spaceship back on Earth, he steps out feeling great. He's exactly 1 year older. But when he goes to look for his brother Chad, things get deeply disturbing. Because for Chad, who was sitting still on Earth, over 22 years have passed. No cap, Brad has literally time traveled to the future. He skipped 21 years of Earth's history just by going really, really fast. And this isn't just theory. We have proven this. We literally have to adjust the clocks on our GPS satellites because they are orbiting the Earth at 8,700 miles per hour, which means they experience time slightly slower than our phones on the ground. If we didn't account for this time glitch, Google Maps would be utterly broken in a matter of days, and you'd be driving into lakes. So speed breaks time. Cool. But what if I told you there is something even more powerful that absolutely cooks the timeline? I'm talking about gravity. Welcome to general relativity. Einstein realized that gravity isn't just a magnetic-like pull between two objects. Mass actually physically bends the fabric of spacetime. Think of the universe like this trampoline. If I drop a bowling ball in the middle, it creates a massive dip. That dip is gravity. And the heavier the object, the deeper the dip. But here's the mind-blowing part. Time flows slower the deeper you are in that gravitational dip. Gravity literally drags time down with it. It has that W-riz on the fabric of reality itself. If you want to see this in action, we have to look at the most unhinged objects in the universe: black holes. A black hole has so much mass packed into such a tiny space that its gravitational pull is practically infinite. Its aura is so overwhelmingly dense that not even light can escape it. If you've seen the movie Interstellar, you already know exactly what I'm talking about. They land on Miller's planet, a world orbiting dangerously close to a supermassive black hole named Gargantua. The gravity there is incredibly intense. Because they are so deep in that gravity well, the time dilation is catastrophic. The formula here involves the Schwarzschild radius, and it looks something like this. T equals sine t sqrt 1 frac 2 gm rc squared. What does that mean in English? It means for every single hour they spend walking around on that planet, 7 years pass back on Earth. 1 hour, just 60 minutes. You could watch a couple of TikTok compilations, and an entire generation back home would have grown up and moved on. The characters literally get back to their ship after a 3-hour mission gone wrong, and their crewmate who stayed in orbit has been waiting alone for 23 years. He is literally cooked. And if you were to actually fall into a black hole, to an outside observer watching you through a telescope, they would never actually see you cross the event horizon. Because gravity gets infinitely stronger the closer you get, time would appear to slow down infinitely. To the observer, you would freeze in place, slowly fading into red light forever. But for you, you'd fall straight in, crossing the threshold in seconds before being spaghettified into your base atoms. Talk about a bad way to log off. Okay, so we know we can travel to the future by going super fast or hanging out near a black hole. But what about the past? Why can't we just put it in reverse? Why does time only have one direction? In physics, there is no real mathematical reason why time has to only go forward. Most of the fundamental equations of physics work perfectly fine whether time goes forward or backward. If I show you a video of a planet orbiting the sun and then play it in reverse, it looks exactly the same. The physics are completely valid either way. But then, we have this. If I play the video of an egg splattering in reverse, you instantly know it's fake. An egg doesn't magically unshatter, uncook itself, and fly perfectly back into a shell. You can never unbake a cake. You can never unsend that cringe text to your ex. The universe simply doesn't allow it. The reason time has a strict, one-way arrow is because of the second law of thermodynamics. It all comes down to a little thing called entropy. Entropy is basically a measure of disorder or randomness in a system, and the fundamental rule of our universe is that entropy must always increase. Things naturally go from order to chaos. Think about your bedroom. If you spend hours organizing it, it's in a state of low entropy. It is highly ordered. But over the week, as you throw clothes on the floor, leave empty prime bottles on the desk, and generally live in it, it naturally becomes chaotic. High entropy. It takes energy to organize the room, but the mess happens automatically. The universe is exactly the same. At the Big Bang, the universe started in a state of incredibly low entropy. Perfectly packed, perfectly ordered. And ever since then, for 13.8 billion years, it has been expanding, cooling, and getting messier. Time only flows in the direction of more mess. If you want to travel to the past, you would have to decrease the entropy of the entire universe. You'd have to force all the broken eggshells in the cosmos to fly back together. And the laws of physics just look at that idea and say, absolutely not. Access denied. The arrow of time is just the universe slowly, inevitably trashing its own room until everything eventually goes cold and dark. Comforting, right? So time is relative, gravity breaks it, and entropy keeps it moving forward. If your brain isn't fully melted yet, let me serve you the final boss of time physics. The concept that everything I just said might actually be completely irrelevant because the past, present, and future don't actually exist the way we think they do. Welcome to the block universe theory. And yes, I brought bread to explain it. Let him cook. Einstein's theories led physicists to a truly terrifying conclusion. If time is a dimension, just like up, down, left, and right, then all of time must already exist simultaneously. This crust over here, that's the Big Bang. These slices in the middle, that's the Roman Empire, the moon landing, and you watching this video right now. And this crust on the other side, that's the end of the universe. In the block universe model, space-time is a giant, solid, unchanging four-dimensional block. Every moment that has ever happened, and every moment that ever will happen, already exists inside this block. We feel like time is flowing because our human consciousness is essentially moving through the block, experiencing one slice of the bread at a time. We are literally trapped in our three-dimensional perspective, reading the universe like a book, page by page. But to an entity that lives outside our 4D universe, say, a 5D being, they wouldn't see time flowing. They would just look at the entire block all at once. They'd see your birth, your entire life, and your death all existing simultaneously, frozen in this cosmic jelly. If the block universe is real, it means the past isn't gone. It's just over there in the space-time block. Dinosaurs are still roaming the Earth right now, just at a different coordinate in space-time. And your future, the job you'll get, the person you'll marry, the day you die, it's already there. It's already happened. The script is completely written. You are just a character playing out the scenes, falsely believing you have the free will to change the ending. Talk about massive NPC energy. If Einstein's math holds true to its deepest philosophical extreme, free will might be the ultimate illusion. Everything you've ever stressed about, every choice you thought you made, it was all baked into the loaf of spacetime 13.8 billion years ago. You're just along for the ride. All right, let's all take a massive, deep breath and snap back to the illusion of now. I know we just went deeply off the deep end. We went from the ping delay of the sun, to Brad aging 21 years slower than Chad, to getting cooked by the gravity of a black hole, right up to the absolute horror that your entire life is just a pre-written slice of cosmic bread. But here's the reality check. Even if the script is already written, you still get the privilege of experiencing the movie. You still get to feel the hype, the joy, and the absolute chaos of being a conscious being in this insane universe. Now I need you to drop into the comments right now and tell me, which time glitch absolutely shattered your brain the most? Was it the twin paradox, the fact that we live 8 minutes in the past? Or are you currently having a crisis over the block universe bread? Let me know down below. I'm going to be replying to the most unhinged comments. If this video gave you a massive brain blast and made you question your entire reality, you already know what to do. Smash that like button. It literally tells the algorithm that we are delivering that WRIZ science content. And if you're new here, hit subscribe and ring that bell. We drop mind-bending deep dives like this all the time, and you do not want to miss the next one. Until next time, Spark Squad, keep your aura high, don't let gravity drag you down, and remember, time might be an illusion, but your potential is infinite. Stay curious. I'll catch you in the next one. Peace.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas, and tell me in the comments what topic we should explore next. Until next time, keep your mind curious,